Yeah, you're here.
Just
Don't come at me like that. I hate her with a burning passion. I may hate myself.
Okay, notes. Today we are going to be doing the second half of dividing polynomials.
Yes.
The first half we did long division, the second half we're going to be doing synthetic division. Long division works on every polynomial division problem. Synthetic division only works when we are dividing by a linear binomial.
What's a linear binomial?
I'm going to show you in a second.
Binomial?
Let's do something that makes a line.
I'm so excited.
It's not exciting.
I didn't even know what synthetic division is without like this root letters. So you know what? Maybe it's not.
It just doesn't look right. That's not exciting.
Hey now.
We have homework tonight.
No.
Yes.
We might be here.
I have to do a chem worksheet and that takes like an hour because I have to teach myself how to do it on YouTube. I just write sit down and I think there's it worked out pretty well. I still have an A in that class. I have an A minus. Some of the thin eyes.
Okay, so synthetic division only works when we are dividing a polynomial by a binomial divisor in the form x minus c or x plus c. So the really key thing here is that c is a constant. X is only an x. There's no number in front of it. There's no exponent on it. Okay, so it only works on a linear binomial like this one. Just like we did with long division, we need to fill in any missing or skipped terms with a 0. That is extremely important here. I love synthetic division. I'm so excited.
I would like to disagree.
You haven't done it yet.
It doesn't.
Do it and then pass judgment.
We can't ruin her glowy.
What if I just say no?
She's too happy.
This is the only thing I've got to teach today. So
I think it's so
I'm
great
very
that teachers
excited.
are happy about
But I
what
give you a
because there's some teachers who aren't.
why men just like not have homework.
you can say white ass brains, not white stuff.
What's aspirin?
Okay, so
You haven't had flora.
Freaking Flora.
Okay. Are we ready for an example?
No.
Yes. Okay.
She's so perfect. This makes me miserable. I mean, this is her job. She's gotta love it. She gotta
Not everyone loves their job.
Your highlighters.
That is true.
Garbage men, I don't think they like their job.
Okay. So the problem we are starting with is the polynomial x cubed minus 6x squared plus 2x minus 4 divided by the binomial x minus 2. We could use long division here, however, we're not going to
Okay.
because I don't want to.
But the long
technically,
division,
I
I
want
want
long
fun.
You can always use long division, yes, but this is faster.
So.
I don't think so.
Unless I say use synthetic division, it is your choice.
If you like never say that, so that I don't have to.
Okay.
Just for.
So when we are setting up synthetic division, if you looked at the notes, you saw that it's a chart. This chart is built off of only the coefficients of all of the terms in my dividend. Okay, so before I fill it in, I have to make sure I didn't skip any terms. So I just look at the exponents. I have a 3, a 2, a 1, and a constant. So I'm good to go. I didn't skip anything there. I'm going to go ahead and drop down these coefficients, and I'm going to build my chart around them. So between each of them, I'm going to draw a vertical line. I'm also going to put a vertical line out front, and then put 2 horizontal lines so I have a chart with 3 rows.
This is fun.
It's really challenging my TV line with this straight line.
Some of mine turn out like diagonal and slanted real bad by the end of
It
it.
doesn't help that I usually write with my paper like this.
That would do it. Okay. Is anybody confused about how I filled in those coefficients? They remain in the same order that they were in for my dividend. If it was a negative, the negative still applies. Okay? Now I have to identify the number that I'm dividing out. So to do this, I go to my divisor, I set it equal to 0, and I solve for x. So I'm going to take x minus 2, set it equal to 0, and solve. That number that x is equal to is what goes in the top left corner of my chart.
Yeah.
Give everyone a second to make sure they understand that.
Sigh.
Some hefty sighs happening right now.
That was a ghosty one.
Anybody confused so far? Okay, so to start the synthetic division process, I go to the first coefficient and I drop it all the way down to the third row.
Fun. So you don't need the second.
We do not need the second row for that coefficient. Anything that ends up in this third row has to get multiplied into whatever number I'm dividing out. Then that product will go under the next coefficient. So in this example, I have 1 times 2 is what?
2.
That number goes under my next coefficient. And then I add straight down. What's negative 6 plus 2? Negative 4. Just like before, I'm going to take negative 4 times 2. What is that?
Negative.
And that goes under my next coefficient. And then I add straight down. 2 and a negative 8 is a negative 6. Then I do negative 6 times a negative 2 to get negative 12. And then I get negative 4 and negative 12 equal what?
16.
These numbers are my quotient and remainder for this problem.
That's it?
Hold on. Does everybody understand how we did that?
Yeah.
If you don't, please say something. Okay, so this is where we work backwards to build our answer. The number in the last box is our remainder. I like to circle it so I remember it's not really a part of the quotient. It's tacked onto the end. The number before that is my constant. The one before that is the coefficient on my x term. The one before that is the coefficient on my x squared term, and so on. I would just keep filling this in until I was out of numbers. Which means that my quotient is 1x squared minus 4x minus 6 plus my remainder over my divisor. And I'm done.
What happened to the x cubed?
Well, when I divided out an x, it reduced, just like it would in long division.
Oh yeah, because you have to like the x squared.
Yeah. Okay. How much do we hate this?
That's
Yeah.
actually
It's not that bad? Okay.
It's still a lot.
I don't like
I am going to say this has way more uses than just the basic division, and we are going to use it a lot more. Okay. If I'm just asking you to divide, though, I'm pretty much going to leave it up to you on what you want to use. Because some people really don't like this. Let's do another one, though. Those were extremely lackluster, but I will take them.
I don't know.
No, I'm genuinely excited for work. I'm genuinely
Yay.
I hate English language. Genuinely. I don't speak high sense. Vodka. I can do Japanese vodka. It's like such a crazy
Yeah, I feel like having
Or they're Chinese.
Japanese.
I did.
Okay, that sounds fun.
You're really. Can we watch a video or something? It's like a fun, like, you know, one of those.
Why don't you just want to watch me?
My
Like a
family
rap song.
watches the regular movies.
You know, it's one of those rap songs. Yeah, he's like, can you rap?
It's just wrong raps, so that's like.
I'll lay
Did
down.
he? I don't know if you guys know Luca
Yeah.
He, in honors pre-calc last year, we did like a review and I let them make like a multimedia thing. And he rapped about polynomials. And his name was Lil Nomeo. It was the best thing ever in my entire life. Somewhere I actually have it. If I can find it, that would be fantastic.
Oh my God, yes, please. I think he still remembers it.
I have no idea. I have the paper somewhere that has like the rap right now. Okay, so now we have the polynomial 2x cubed plus 8x squared minus 8x plus 16, all divided by x plus 4. What's the first thing I need to check for? Sam, sorry.
Can we move a little slower because you lost me?
Yeah, absolutely. What is the first thing that I need to check for before I set up my synthetic division chart?
That we did not skip the sum.
That we didn't skip anything, that all of my x's are there. If they're not there, what do we fill it in with?
A 0.
A 0.
Wait.
Okay.
Does that mean if we just put a 0 in the box?
Yeah, we would just put a 0 in the box. Okay. So what I'm going to do now is I'm going to pull down each of these coefficients and build my box. So the first coefficient is a 2. Then I have a 1 because there's nothing in front of my x squared, so we have to assume it's a 1. We bring down the negative 8 from the x, and the positive 16 that is my constant. I build my chart, leaving an extra box in front of my leading coefficient of 2.
And we said that.
Hold on. Miranda, how do I find the number that goes in that first box? What do we call that? What's its special name? Starts with a D. Other one. Divisor. Good. This is the dividend. The bigger one is the dividend. I always remember because dividend is a bigger word than divisor. So I take that x plus 4 and I do what with it?
Then you go to 0.
And solve. And I get x is equal to negative 4, and that's the number I fill into that top left box. We all okay? Kendra, what do I do next? Why do I drop the 2 down? Because it's the first coefficient. We always drop that one. All the way down to the third row. Reese, what do I do with that 2? Multiply it to the negative 4, and its answer goes where? Under the 1, which is our next coefficient. So Sam, what's 2 times negative 4? So I put the negative 8 under the 1, and I add straight down. What's 1 minus 8? I'm hearing like 3 things.
Negative 7.
Negative 7.
I was right.
And then we'll pause. Anything that ends up in that third row, except for the very end, gets multiplied into the divisor and then put under the next coefficient. Are we kind of okay with that?
Yeah.
Yep, and it drops onto the next one. So Xavier, what would I do with that negative 7? And what does that equal? What's negative 7 and negative 4?
28.
Positive 28, and that number goes where?
Right below the negative 8.
Under the next coefficient, which is negative 8.
Then you get 20.
Then I do negative 8 plus 28 is a positive 20. Hold on. Then I do 20 times negative 4 is negative 80. And then I do 16 minus 80, which is negative 64. So then I go ahead and I build my quotient and remainder. My remainder is the last number in the bottom row. The constant is the number before that. The x term is the number before that. And the x squared term is the number before that. So I go ahead and I write my quotient, just applying each of these numbers to their respective variable. So 2x squared minus 7x plus 20 plus my remainder over my divisor. How do we feel about that?
Good.
Good. Anybody super duper hate it still?
I like it.
Caitlin? Do we super duper hate it still?
Only slightly.
Only slightly. See, it's getting better.
I still don't like it, but I mean.
Does anybody already like this way better than long division? That's usually how it goes. Okay, so let's go ahead and do another one. Because I know you guys are just having a blast.
I am.
I would actually like for you to do this one on your own. That's what I'm going for here, okay? You guess.
Give me 2 E.
I know.
It's X.
No, wait.
Wait a minute.
No. It's okay, guys. It's just zero. It makes our job easier.
What don't we like about this one?
I don't want to say before.
The exponent or the coefficient? The exponent? That happens. We can honestly have a polynomial like x to the 7th and do this.
But I don't.
Doesn't change the process at all. What else do we not like? We skipped a term. How do I know that we skipped a term? We look at our exponents. I went from a 4 to a 2. What number is between those two? So we need to fill this in with a 0. So I'm going to have 4x to the 4th plus 0x cubed minus 2x squared plus x plus 1, still divided by x minus 1. And now you can build your synthetic division chart.
Wait, so you, for the thing, you like add or subtract them?
Which thingy? Like when we go down the chart?
Yeah.
We add straight down.
Okay.
Give everyone a chance to build this and to do it, and then we'll do it together. And move this up a little bit. Thank you. Oh, You're that's not correct. I didn't give you any. Keaton, talk me through this.
So you gotta do x minus 1 equals 7.
And what do we get when we do that? Fantastic.
Then you make it so you put over 0, -2, 1, 1.
Then what?
You put the 1 the x on the top. You chop down the 4 to the bottom. 4 times 1 2 plus 4 4 times 1 4 -2 plus 4 is -2 and 2 times 1 is 2 2 plus 1 is 2 plus 1 is
Christina, what is my answer then? My quotient from dividing. Say that louder, I can't hear you, honey.
I don't know if I should.
Well, how do we build my quotient from this? Do I start on the left or on the right? On the left? Do we start on the left or on the right? The right, because this last number is what? The remainder. And then I build backwards from there. So what's the number in front of my remainder? The constant. What's the number in front of that? And the number in front of that? And the number in front of that? And then I just put those coefficients on each of those variables. So I end up with 4x cubed plus 4x squared plus 2x plus 3 plus my remainder over my divisor.
Probably the most fun I've ever had.
Woo, Sam.
Why do you have an extra 1 on the right side? Like on the top.
Because the coefficient in front of x was 1, and then the constant was also 1.
I did not write it down.
That's okay. It's really easy to get lost with the coefficients when they start repeating themselves. Issues, questions, concerns? No, I'm going to have you do one more, and then I think we're going to call it, because it doesn't really get any harder than
Do
this.
we have any assignments?
No, there's no homework tonight.
So no like class assignments either?
No.
It's 12:49.
Perfect. Look at that. You got plenty of time to do some work.
Yeah, hopefully we do something after we finish it, because I don't want to do work and throw it. We're almost done with it.
No. It has lots of
I said I think in our I'll try.
And we also have questions.
Oh my God.
Okay, on your own, finish this out, please.
Yeah, it's just in a weird format. You just have to put a bunch of zeros in there. Q plus x squared plus 0 x squared.
You take factors of the constant over the factors of the leading coefficient.
Minus.
So factors of the last number that has no variable
For the top one.
over factors of my leading coefficient. Well, what's my leading coefficient?
X cubed, and then you need
That's why.
x squared, so there's 0x squared, and then that's your normal number. Oh, there's there's 2.
I was right. No, that was the right one.
I forgot that there has to be a singular x. Yes, Patty, we know you're super brain scientist.
I know.
Yeah, she's a rocket scientist. Yeah, but with brains. There's 2.
I actually do better this time. Say that now. I'm gonna write amazing shit.
Well, there's no.
You say that now.
I was like, dude, that's
Well, this is the only thing I'm gonna figure out. Anything else you want on that shit? That's what you say now, right?
This is easy to remember.
Yes, let's go.
Okay, because I don't like it. You're right.
Elijah, you are up.
Well, I'm okay with cooking. I don't want to
That's my most present list right there.
That's
I could face anything that.
Oh, I know.
The one side.
I'm not there's one that's important to read up. She is, she's a vampire, she's literally pale and she's got like a cross on she's got dark hair. Wait, what is that? You're also feminine and Spaniel. Yeah, she knows how to cook people. Watch out. Can we recreate, what's that one?
Okay.
I'll be
So Elijah got x squared plus 4x plus 16. Show of hands who else got that quotient.
Wait,
If anybody confused or not understanding how we got what we got, or set up the chart.
So we don't put 0 over x minus 4?
No, because the remainder of 0 is just 0. 0 divided by anything is just
So
0.
what do you think would?
No, that's fine. However, that brings up an interesting point that I mentioned when we did the original lesson. What was my remainder here? 0, which means that x minus 4 divided evenly from x cubed minus 64, which means x minus 4 is a what to that polynomial? A factor. Okay, so we're not actually practicing this yet, but it's good to know because we will be. In fact, we're going to introduce some theorems about it when we come back from break. I know, super exciting. Anytime you get a remainder of 0, it divided evenly and is thus a factor of whatever we divided it out of. By it being a factor, that means it's also a 0, a root, or a solution to that polynomial as well. Okay, so that's the end of my spiel. Tomorrow you're going to do synthetic division practice with your group. And then after break, we're going to do some more with this.
I still don't want
No homework tomorrow, Madison. It's all going to be partner practice in class. So this is it. I'm going to go ahead and stop the recording, and then I'll be on here in case you guys have any questions, but there's no homework today or tomorrow.
To be a badass baby vampire that like